Hello everyone, this is Project 8. This is a continuation of Project 7. Here we are going to access the web servers from a single point of access called a load balancer, which is what we are going to implement here using Apache. You can also look up Nginx and some other servers used for load balancing. Let's read through the documentation. After completing Project 7, you might wonder how a user will be accessing each of the web servers using 3 different IP addresses or 3 different DNS names. You might also wonder what's the point of having 3 different servers doing exactly the same thing. You see, the thing is, when we actually access a website on the internet, we use a URL, and we don't know how many servers out there serving our request, how many underlying servers, also called server pool or server farm, serving our request. This complexity is usually hidden from a regular user, but in case of websites that are being visited by millions of users per day, like Google or Reddit or Twitter or any hot website, anyway, it's very important to serve all the users. It is impossible rather to serve all the users from a single web server. It's actually not feasible because that single web server will crash in no time. This is also applicable to databases, but now we'll focus on a web server. Now, each URL contains a domain name part. That domain name part is what we know as the names like www.google.com. That is the domain name. Actually, this domain name is usually mapped to an IP address, such that when you type in the domain name on your browser page, it actually resolves to the mapped IP address of the target server. So we get the page that we actually want. This is made possible through DNS. Let's browse about what DNS actually means. So a domain name system is a hierarchical and decentralized naming system for computer services or other resources connected to the internet or a private network. Or we can actually go over these later. Let's go back to the documentation. The most commonly used one has a public IP address 888 and belongs to Google. You can try to query it with ns lookup command. Now let's try that now. Let's go to our terminal and let's try to follow the documentation. It says let's type ns. Let's use it Ubuntu ns lookup 8.8.8. Now you can see name DNS Google, exactly as said in the documentation. Let's move on. Now, when you have one web server and load increases, you want to serve more and more customers. There are 2 ways to this. You can usually add more CPU or RAM, or completely replace the server with a more powerful one. This kind of approach is called a vertical scaling, but it has limitations. As I said, at some point you can reach the maximum capacity of CPU and RAM that can be installed into your server, and after that the server will crash. Another approach that is more workable and is used to cater for increased traffic is called horizontal scaling, distributing load across multiple web servers. This approach is much more common and can be applied almost seamlessly and almost infinitely. For example, Google. You can imagine just how many servers there are in Google that serves billions of search requests. Horizontal scaling allows to adapt to current load by adding, which is called scaling out, or removing, which is called scaling in web servers. Adjustment of number of servers can be done manually or automatically. For example, based on some monitored metrics like CPU and memory load. Manually, it's going to be tedious. Most usually, it is done automatically through an approach called auto scaling, which will be discussed later in other projects. But for now, let's stay within the documentation here. The property of a system to be able to handle growing load by adding resources is called scalability. So in our project 7, we had 3 web servers, and each of them had some public IP address and public DNS name. The client has to access them by using different URLs, which is not a nice user experience to remember addresses, numbers and names of even 3 servers, let alone millions of Google servers. Yeah, that's actually not feasible. So instead of all that, so to hide all that complexity and all, you have to have a single point of access called a load balancer that only has a single public IP address and name. And usually users are usually concerned with just name. So what a load balancer basically does, it distributes clients' requests among underlying web servers, which are also called web server farms or server pools, and make sure they are distributed in an optimal way. The distribution actually depends on the load balancing algorithm. There are different kinds of load balancer, and the choice of load balancing method depends on the on one's need. So let's check this site self-study to have a grasp of what load balancing concept mean and the difference between layer 4 network load balancing and layer 7 application load balancing. I also implore us to check OSI layer in networking, so you can get a grasp of what this layer 4 network load balancing, this layer 4 network load balancing and layer 7 application load balancing means. Let's click on this and check. Alright. Load balancing refers to efficiently distributing incoming network traffic across a back-end servers, also known as a server farm or server pool. Alright. So the functions of load balancer: distributes clients' requests or network load efficiently across multiple servers. It ensures high availability and reliability by sending requests only to servers that are online. Provides the flexibility to add or subtract servers as demand dictates, that is scaling or scale out, as said earlier in the documentation. This is an architecture that represents a load balancing system. Now these are the servers, the web servers, the application servers. Now this is the load balancer. There are 2 kinds of load balancer: the hardware load balancer and the software load balancer. That will be discussed later also in other projects. And this is the internet, the medium through which the client accesses the web server through the load balancer. So when the client actually accesses the internet for information, what is actually what the traffic is directed to the load balancer, which in turn accesses the web server for the information and routes the traffic to the web server through the load balancer. Let's move on to the documentation. Now let's try to implement the project and successfully implement this architecture. By the way, this is my web server. This is web server 1. You can see it's loaded already. Everything is working all right. So let's go back to our projects. All right, now so it says we should create an Ubuntu server instance and name it project 8 Apache LB. So it will look like this. All right, let's do that now. Alright, having done that now, so let's log in into the terminal. So what we're going to do now is take the public IP address, go to our terminal, let's try to create a new. Alright, let's rename this to LB. So now this is the load balancer terminal. So let's go back to the documentation. So let's open port 80 in the inbound role in security group of the AWS. So let's do that now. Okay, I haven't done that. So let's try to run this command. So we're installing Apache now. We're installing Apache server that's going to serve as our load balancer. Okay, so let's install the dependency next. So let's install these following modules that will enable our Apache to work well, and we'll be able to configure it as we want. Okay, we've done all that now, so let's follow the instruction here. So to activate all this new configuration, then we're going to have to restart our Apache. So let's do that now. Okay, now that we've done that, let's go back to the documentation. Okay, we've already done that to restart Apache 2 service. So let's check the status of our Apache server to see if it's running. Okay, we can see it is running and nothing is wrong with it. So let's move on. So it's time to configure the load balancing. Now this is the config file, the default config file of Apache server. So we're going to enter this default config file and configure some commands in there. So let's do that now. Let's clear our terminal. Okay, having done that, according to instruction in the documentation, we have to make sure we paste our barebone configuration inside this folder here. So let's try to okay, so this is good. Let's go back to the documentation and copy this. Now, what this configuration is telling the Apache server is to actually map the IP addresses, the web server IP addresses to this load balancer, such that we can actually reach the web servers from the load balancer. The load balancer can distribute traffic to the web server efficiently. So this is what this configuration is all about. Now here we are going to substitute this for the proper website IP address. So let's do that now. So we'll copy this. We'll paste it here. We'll do the same for the web server 1 too. copy this, then we'll paste it here too. So our work here is done. Let's try to see what this load factor and timeout actually means. Let's follow the documentation. Now you see, as I said earlier, there are different kind of load balancing method. So in Apache, there's a load balancing method called by traffic. It's going to distribute incoming load between your web servers according to the current traffic load. There's another one called load factor. We can control in which proportion traffic must be distributed by the load factor parameter. So these are load factor parameters. So this load factor here actually controls the proportion which the traffic is distributed by the by traffic method. There are other methods. There are other load balancing methods in our Apache server. There's the by business, the by request, and the add bits. So let's try to see what they're all about. Okay, as we can see, all these load balancing methods are actually load balancing algorithm. Let's try to read more on all these load balancing methods to get a proper perspective of them all. Okay, so let's go back to our terminal and save. Okay, let's try to restart our Apache to see if everything. So everything is running. No, I'm trying to restart. Sorry. Okay, everything is fine. So let's copy the load balancer IP address or DNS name and append index.php and see if we'll be able to access, if we'll be able to see our browser page. Alright, let's do that now. So copy the public IP address. Okay. As we can see, the load balancing, the load balancer works out fine. So we got that correctly. So this is the load balancer. This is the web server 1. This is the web server 2. So now when clients try to access information, now the load balancer accepts the traffic and distributes it properly according to the load balancing method that was chosen. Here, let's look at the notes. It says here, if in the project 7 you mounted var/log/httpd from your web servers to the NFS server, unman them and make sure that each web server has its own log directory. Okay, so how we do that is the command to do that is sudo umount -f to force the unmounting in case it persists, it's in use. So the umount, then the file path /log/httpd. Am I right? Yeah, I'm right. So that's the command to do that. So let's try to see the access log of our web servers. Oh, sorry. Okay, let's go to our web server 1 now. Let's see. Alright, as you can see. So these are the server requests from people who try to access these web servers. So every attempt to access the web server is logged in here, so we can know from the IP address, we can know the location, the kind of machine used to access, and so on and so forth. Here it says Chrome, and of course I'm using a Chrome browser. So let's just move on to let's move on to the next step now. Now, as we said, if we try to refresh our web page several times, let's just try it and see what will happen now. Okay, this is web server 1, and okay, let's do that for web server 2 too. Okay, now let's try to look at the log again. Here, as we can see, the access log has increased. It has logged more information on people who try to access the web page, which is us. As we can see here, this is us trying to access the web page for web server 1 and also web server 2. So I hope this is very clear to us. Let's move on to the next line. So the number of requests to each server will be approximately the same, since we set the load factor to the same value for both servers. It means that traffic will be distributed evenly between them. So that means this load balancer here will distribute traffic evenly between the web servers, since we set the load factor earlier to approximately the same value for the two web servers. Let's try to read more on all these terminologies to get a very good grasp of them. Okay, these are on the site self-study here. Let's read more different configuration aspects of Apache. Okay, let's click on it and see what it's about. Okay, now as we can see, it's more information about load balancing methods and all. The load balancer stickiness. So the mode proxy balancer implements stickiness on top of two alternative means, cookies and URL encoding. Let's try to find out more on cookies and URL encoding. We understand a lot better on cookies and URL encoding that we usually see on websites that we try to access, but you don't know it is. Reading about this will give you more perspective on those terminologies. The mode proxy balancer implements stickiness. So what's the stickiness concept? This is more or less the meaning of stickiness. When a request is proxied to some back end, then all following requests from the same user would be proxied to that same back end. That's essentially the meaning of stickiness. Many load balancers implement this feature via a table that maps client IP addresses to the back end. This approach is transparent to client and back end, but it suffers from some problems: unequal load distribution if clients are themselves hidden proxies, stickiness errors when a client uses a dynamic IP address that changes during the session, and loss of stickiness if the mapping table overflows. So we can see that stickiness isn't without its disadvantages. Anyway, let's go back to our documentation. So let's try to implement this optional step. Let's configure local DNS name resolution. As I said earlier, it is not very easy to actually remember and switch IP addresses, which are essentially numbers, especially if we have a lot of servers under our management and all. So the way to do this, so let's try to map a local domain name. Let's try to resolve a local domain name to our IP address. So that's what we'll do now. So to do that, we have to enter into the /etc/host file and paste this configuration there. So let's just do that. But first, let's try to alright, let's paste this here. Alright, so now let's open this /etc/host file and paste in this new record. So let's go to load balancer. So let's open the file. Alright, let's copy and paste what you just did here. Okay, so we just registered this new record. Now let's just see what we do after. So let's just save and exit. Alright, after that now let's update our load balancer configuration file with those names instead of the IP address. So let's do that now. So we'll open that default Apache default configuration file that we opened earlier, this, and we'll replace the IP address with the new DNS names we just resolved locally. Let us not forget there is a local DNS name resolution, so it applies only to this server, to this load balancer. It cannot be used to it cannot be accessed by other servers or even from the internet. It only applies on this load balancer server. So having done that, let's save and exit. Alright, now what next? Okay, so let's try to call our client URL, because this URL means client URL. So let's try to call our client URL from let's try to call our client URL, which are the web servers from the load balancer. So let's see that now. Let's try to do that now. Okay, let me copy the command. It's easier that way. Let's see what we'll get. As we can see, this is a HTML formatted version of this. This is a UI appearance, So this is the codified version, which is in HTML mostly. As we can see, that's web server 1. So we are able to call our client URL, which is web server 1, from the load balancer, which means the local name resolution works for this load balancer. Let's try to call web server 2. As you can see, it's still the same thing too. So that means all our configuration works out fine. As I said earlier, this local name resolution, it's only an internal configuration and it's only local to your load balancer server. So these names will neither be resolvable from the other servers internally nor from the internet. As I said earlier, this only applies to the load balancer. So we are able to achieve this architecture. So thank you very much for this project implementation. More project implementation on the YouTube channel. Thank you very much.